Hello again, you sick, twisted weather freaks, and welcome to a special edition of This Week in Weather. It's time to do my winter forecast preview. So this video is going to be talking about how I see the winter shaping up. And this is probably going to be a little more comprehensive than what you usually see, but I do things differently. And if I see, different data, I'm going to talk about things differently. That's just the way I roll. So let's get started. We got a couple sections here to talk about. The recent winter trends, the La Nina in the winter coming up, the QBO, some other variables in my preliminary forecast. So here we go with the recent trends. And you can see this is now, this is the 19th all the way to the 23rd, 2019 to the 23rd. And you can see how extreme the snow drought has been in the Northeast. I mean, even in North Carolina, which they don't get a lot of snow, but you can see that over the last 4 years, it's been pretty darn extreme. And that also extends into much of the Midwest. Now, normally, of course, they have been getting snow here, but normally their snow amounts are much, much higher. And you can see these orange colors here, 40, 50, 60 inches below normal snowfall. The yellow here is 72 inches or more over the last 4 years in the snow areas of eastern West Virginia, western Maryland, southwest Pennsylvania, upstate New York, the Great Lakes, much of New England. Even the Midwest, South Dakota, Iowa, Wisconsin, Illinois, 12, some areas not too bad, Illinois, Indiana, but some areas are 20, 34 inches below normal. Quite impressive. And the trend has been going on for a while. This goes back to 1970. So this is more than 50 years of data. And you can see over the last 53 years that the snowfall amounts, areas less snow, you can see all the purple dots here, about 64% of the country. About 36% has seen some above normal snowfall over the last 50 years, but that's mostly been concentrated here, not so much in the Mid-Atlantic or the Ohio Valley or the Tennessee Valley areas. These marginal areas have seen a big drop in the snowfall. Of course, it doesn't change people from over forecasting snow. You can see this was the Farmer's Almanac from last year, 23-24. Boy, that was awful. This may have been one of the worst, I guess, forecasts. I'm not sure if the Farmer's Almanac counts as a forecast, but people look at it. That's pretty bad. And then, of course, the other one is no different. But here's the latest ones. You can see the new Farmer's Almanac on the upper left, the one on the bottom right is the other one. And you can see that both are 20, 24, and they're much warmer. Look how much wetter they are. A lot less snow here. Warm and mild and dry, completely different. Warm, cold, wet, and white, mild. Just much less snow than what we saw in the last several winters. I mean, this has been going on for like 3 or 4 winters. You can go back and look at the Farmer's Almanac of 22, 23, 21, 22, and it's just constant snow. It just hasn't showed up at all. So now they're going the other way around, so we'll see what happens this winter. All right, this was the last really I would consider good winter in the Midwest, the Mid-Atlantic, and New England. And by good, I mean active winter where you actually had decent snow in some areas above snowfall. So even in the Virginia Piedmont, the Richmond area, D.C., where they don't get a lot of snow, Charlottesville, you can see the winter was pretty good, anywhere from 12 to as much as 24 inches of total snowfall. And then into southern New Jersey. And then you can see New England got really pounded, northern Minnesota, Wisconsin, the Great Lakes, go to snow in the Ohio Valley. So it was a snowy winter. That was the last good snowy winter. This was the winter of 2021. This one wasn't too bad. The snowfall was kind of sparse here in Virginia and Delmarva, and then western Kentucky, but the other areas weren't too bad. They were a little below normal, but not that much. And then we saw 21-22. Again, kind of a mixed bag. Also, marginal conditions in Mid-Atlantic. That yellow color there is about 1 foot of snow for the season. And that's, if you were to blow this one up, I think I can. Let me blow it up a little bit. You can see that, in Northern Virginia, that wasn't too far off normal. It was way below normal, Pennsylvania, New England. The Ohio Valley is below normal. Look at the anomaly here in Nebraska, Iowa, Wisconsin, South Dakota. Look at that gigantic snow hole in Nebraska. Whew. I mean, you go through the whole winter of Nebraska and you only get 6 inches of snow. You got a weird winter. And you could see that. So, but again, 21-22 was a weird winter, and it was not a pretty snowless winter for a lot of places. And then here we can look at 22-23. We can see again 21 to 23, 22 October to February 23. Look at the snow anomaly, unbelievable. And you can see this is the actual snowfall amounts relative to normal Okay, actually you can see here, and then this is the percentages of normal. And you can see these amazing anomalies. So the snow draft's been going on a long, long time. All right. So, right, this is the last winter, the 23-24. Just to briefly remind you what happened, we had an El Nino. You may remember that. We had a strong El Nino. Okay, it reached up to around almost a couple times. It reached plus 2.0 degrees centigrade in ENSO region 3.4. That's the important region. We'll get to those regions in just a second. The El Nino or La Nina, it's actually called ENSO. That region along the equatorial Pacific consists of several different areas, and I'll show you a map about that in just a second. But here you can see the blue arrow. This was as of November 16th. Look at the warm water here off the coast of Japan and the northwest of the Pacific. And the green arrow shows a raging El Nino here. And it continued. This was January 31. It didn't show any signs of weakening at all. Continuing. Widespread El Nino across the entire equatorial Pacific. And the pool of warm water in the northwest Pacific. Now, all along the coast of the United States, temperatures are fairly close to uniform normal. But relatively speaking, this pool of warm water and this pool of cold water produces what we call a negative PDO, the cold water, and that favors troughiness on the west coast. That was another problem with the winter 2 years ago. I should say last year. And you can see the snowfall maps, if you want to call these the snowfall map. Look at this, is pitiful. Whew, just pitiful. And the anomalies were way off. I mean, just way off. So you look at that map and you just shake your head. You're like, wow, that's bad. I mean, New England, it was bad. New England is bad in Pennsylvania, New York. It's awful in the Mid-Atlantic. Ohio Valley is pretty bad. It was just bad everywhere. What can I tell you? Okay. So that was last winter. And if we look at it enlarged a little bit, I got these here from the folks over at Capital Weather Gang, as you can see. And you can see this was the actual snowfall, the northeast quadrant snowfall amounts. Notice almost nothing in Richmond at all. And then D.C., it's about 8-10 inches for the winter. Same thing with Charlottesville. And a little better in Pennsylvania, eastern West Virginia, western Maryland, but still below normal. And you can see the anomalies. I mean, let's just look at the quite a bit. So I guess only upstate New York and northern New England had slightly above normal snowfall. All right, now here we go talking about the upcoming winter in La Nina. So looks like a weak La Nina if it shows up, but I'm not sure it's going to show up, and that's really the heart of this forecast. So this area is the El Nino region, and let me blow this up so just in case you don't know this. You should, but if you don't, that's okay. It consists of several areas along the equatorial Pacific. That's South America, there's Australia, and there's New Guinea, right? And you can see there's Hawaii just to the south. So it covers all the way from off the coast of Peru out to about 160 degrees east longitude. And there's the international date line. The area we're talking about that's critical is ENSO 3.4. That's the critical region that determines whether we are in El Nino or La Nina or neutral conditions, all right? So that's what we want to focus on. So this is the CPC forecast. And you've probably already seen this. This is standard. It's like the Climate Prediction Center has a standard a template, I guess that's the right word, for rainfall and precipitation and temperatures. So some years you might have a little more green in the Ohio Valley or a little more brown some areas, but this is essentially a template. So whenever there's a La Nina, boom, they bring out the template and it's exactly the same. You can go back and take a look at the template, the CPC forecast for the 22-23, 21-22, and 2021. We had three. Those are the three La Nina years, and they all look exactly the same. So that's what they do. And there's a reason for that, because if you look at the general climate climatology of La Ninas, and this shows you what happens. So this is your, you can see here, this is your precipitation bias, and you get above normal in Pacific Northwest into Idaho, and then South Ohio Valley into upstate, well, a little bit of western Pennsylvania, upstate New York, northern New England. And you have below normal in the southeast from, let's say, D.C. and Virginia down towards Texas. And then these are temperatures, and you can see we generally have above normal temperatures here from Texas to Virginia and into Illinois and Ohio, and then below normal on the west coast. That's generally what happens in the typical La Nina. That's just what it is. But the problem is there are variations of that. And if we look at the current La Nina, this is where it's running. So this is as of November 7th. This is reaching 3.4, and you can see it's trading, there's the zero line. And if you can't see, this is a minus 0.1, and this is minus 0.5, so it's like bouncing around in this area. And this is the 15-day mean average. And again, you can see it's dropped down to here, and early October, and now it's hovering in this range. And this is not cold enough to produce a La Nina. It just isn't. It's got to be below minus 0.5 centigrade. And it's not. It just isn't. So I don't know if we're going to get to La Nina. That's really what the issue is. Again, we have to beat the threshold. That's the critical threshold right here. See it? Minus 0.5 C. And now if you look at recent trends, this is a nice graph here from Jan Null over at Golden Gate Weather. He produces this very nice graphic. And you can see this goes back all the way to 1951. And you can see the El Niños, weak, moderate, strong, very strong, and La Niñas, weak, moderate, strong, bouncing around. This was the one last year, 23, 24. We were strong, almost at the threshold of very strong, not quite. This was the strongest one on record, 15, 16, and of course 97, 98, and then 82, 83. But so that's where we were last winter. Now, we're not in that now, where the question is, are we heading towards La Nina or are we neutral? This is another way of looking at it. It just breaks it down into categories. And again, you can see under strong category 23, 24, that's where the El Nino was. Notice there are no super La Nina events where they've never seen one. We've only had weak, moderate, and strong. Now, if you look at the list for weak La Ninas, one thing you'll notice is that there's quite a number of winters in there that were pretty good in the central and eastern U.S. Not great, but pretty good. 71, 72 is pretty good. 64, 65. 84, 85 was a good winter. 2005, 2006. 2016, 17. 2017, 18. So, there are some decent winters there. Now, typically what happens is, all right, so this is the typical El Nino, La Nina 500 millibar pattern. So this is El Nino. Let's talk about that one first. And what happens is you get a negative anomaly in the Pacific. You see that? Then you get a big ridge here in Western Canada and sometimes some blocking in Northeast Canada and Greenland. And this creates a split flow. You have your southern jet stream coming in here. Then you have your northern jet stream dropping down, and you get storminess when the two jet streams mix, right? That is what happens with the typical El Nino event. Okay. This is La Nina. All right, the image on the right is La Nina here. And what's different is, well, it's pretty obvious what's different. You can see. Here is, instead of a negative anomaly, you have the positive anomaly in the Eastern Pacific. And instead of having a positive anomaly or ridge in Western Canada, we have this big negative anomaly or trough. So what happens is the trough dominates the pattern across the western U.S., and you end up getting a ridge along the southeast U.S. coast, which restricts cold air. It prevents big snowstorms on the east coast. It's just all around a real problem. Now, that is the typical La Nina pattern. All right? Okay. Now, this is the climate models, the European climate models, and the CFS. In the blue line, you can see the CFS right here. All right? This is as of October. And you can see that CFS is much colder. Here's the European, the French, the British, the German, and the European ensemble, super ensemble. And you can see all of them are, this dashed line here, that's the minimal threshold for La Nina. And almost all of them are at it or above it. They're just not, they're showing a very weak, and like I said, most of these models do not show La Nina. As you can see, the CFS is much, much colder than any of these other models. So that should be a warning sign that maybe the CFS is overdoing this, or maybe the European climate models aren't cold enough. But there is a discrepancy here. I guess that's the correct word to use. There is a discrepancy, and it should be a warning sign that there's something to watch out for. I don't think the issue is settled right now whether we have going to have a weak La Nina or neutral conditions. This is the European climate model. Came out November 5. And here we can see the same sort of thing. Now, the thick red line is the ensemble mean of all these 50 different thin red lines. And you can see, here's the minimal threshold where the blue color is. See this? Minimal threshold La Nina. It just barely gets there in December, January, into February, and then it's gone. Now, the thick black line was the one for October 5. So it's a little colder, but it's still, this is very, very weak La Nina conditions. So, that's what we're looking at, from what I can see. And here is, now this next image, this shows us the CFS as of the November early projections. I think this came out November 6th, November 7th. And you can see here that the dashed black line is the ensemble mean of 7 other climate models. You can see them. Let me blow this up a little bit. So again, this is region, notice again, region 3.4, just like here, region 3.4. That's what we're focused on. Here, region 3.4 ENSO. So let's blow this image up a little more so you can see it in more detail. Okay, and you can see the different climate models here. Now the dashed black line is the ensemble mean. So around January, it's where it reaches its peak, just around 1 degree centigrade. And then after that, it falls apart in February and March. So this will imply that whatever impacts we're getting from La Nina is in the first half of the winter, the second half, it kind of weakens and falls apart. And indeed, that is what the CFS model is showing. Now this is as of, when was this? This was in November 4 from last week. And you can see, again, the dashed black line, which is the ensemble mean. Let me blow this forward here so you can see it. There you go. And you can see, let me bring this up. Go. There's the dashed black line. It gets just around to minus 1 degree centigrade in December. But by January, look at the line here. This thing is coming to an end. It's already weakening in January, by January 1st. And then in February, March, it's completely gone. So this is a very short duration La Nina. Short duration La Nina, only lasting a few months. Short duration of La Nina. It's over by February. That's the point here. This is not a long duration La Nina event. So if you're comparing all La Ninas, well, some of them lasted 2 or 3 years. That's not the same thing as what we're going to see here. So you got to be careful with that. And let me show you what I mean. Let's take a look at La Nina patterns. Now here is from November all the way through March. The one on the left is moderate La Nina. And look at the difference. This is weak La Nina. Look at the difference at 500 millibars. These are not the same weather patterns at all. Weak La Ninas almost look like a regular, ordinary, decent weather pattern for the winter. There's a moderate ridge on the west coast. Okay, bit of a split flow. So a trough on the eastern United States. The moderate or strong ones, you have this big negative anomaly from the Rockies in the western Canada, a huge ridge in the central and northern Pacific, and a ridge on the southeast coast. These are not the same maps at all. So if you put them all together and you just use a regular template and think the weak La Ninas are the same as moderate or strong ones, you're going to be wrong. That's not what the data shows. Again, another example. This is La Nina temperatures, weak La Nina temperatures. We have 8 images to look at here. Of the 8, 2 of these 8 were featured much above normal in the eastern U.S., as you can see. Here, 2022, 23, and 2016-17. But the rest of them, this is almost normal, 2005-6, 2017-18 was normal, but the other 4 of them had below normal temperatures in the Midwest and the Northeast. And as almost near normal or slightly below normal in the Deep South. So weak La Ninas are not the same thing. That's what I'm trying to get across here. Okay, these are weak La Nina precipitation maps. Okay, we have 12 of them here. Now, of these 12 maps that show weak La Nina, in the Deep South, 6 of the winters had below normal precipitation, 3 were near normal, 3 were above normal. On the East Coast, 5 of the 12 had below normal precip, 2 had above normal, and 5 had winters with near normal precipitation. And in the Midwest, only 1 of the 12 La Ninas featured a winter with below normal precip, 6 of them had near normal, and 5 saw above normal. Okay, so my point is, weak La Ninas are not complete disasters for the winter. And I think people are somewhat pessimistic because of the last 4 winters about what this winter is looking like. Okay. Now, suppose there is no La Nina. Okay, suppose these European climate models are correct and it falls apart. Or it falls apart by late December and it's a very short duration La Nina. What does that look like? Well, this table goes back to 32 years. Now, the data goes all the way back to 1945, but you look at the last 32 years. First thing to notice is that there's only been 7 winters in the green where we've not had a La Nina or El Nino of some capacity. And that's partly because the climate is changing. We used to get these a lot in the 50s and 60s and 70s, but since, almost since 2000, we have a tremendous number. Some of these La Ninas, look at the one here, 89, 90, 92,000, 2000, 2001. This La Nina lasted 3 years. The one a couple years ago lasted 3 years. So we've had a lot of anomalous problems in the equatorial Pacific and El Nino and the ENSO regions. But here we have 7 winters in the last 32 years, which have been normal in terms of the sea surface temperatures in the El Nino region. All right, well, what do those winters look like? Suppose that happens. What does it look like? Well, not bad. Okay, going back to 1950, we've had a total of 19 winters overall. which I featured neutral ENSO conditions. The map on the left shows the temperature anomalies across the CONUS from December to February. The image on the lower right is January to March. And you can see they're almost the same, but it's a little colder in the second half of the winter. Now keep in mind here that the climate regime was much colder than it is now in the Northern Hemisphere in the 50s and 60s and 70s. Even so, neutral ENSO favors winters with readings that appear to be either normal or somewhat below normal for a good portion of the central and eastern U.S. So keep that in mind if we end up getting neutral conditions. In terms of precipitation, well, here we go. It's about the same as it usually is. It's fairly dry in the deep south up into the Ohio Valley. That's fine. And northern New England. And then this is January to March. It's a little drier here if we have neutral conditions. But not that dry in the southeast states. Interesting, over into Virginia. Okay. Let's talk about the QBO. All right. QBO here, we know what that is. Well, let's go over it briefly. The QBO quasi-biennial oscillation is a regular variation of winds at the very, very top of the atmosphere, okay, into the stratosphere, okay, almost where the atmosphere ends when we begin to get outer space. And it exists along the equator at about 30 millibars, the very top of the atmosphere. These strong winds travel around the planet every 12 to 16 months, and then they change direction. So a full cycle takes 22 to 38 months. And it makes it a regular variation. So the idea is knowing the intensity and direction of the QBO, as well as how important it is in trending, can be a clue about the forecast. The QBO winds and the jet stream winds affect the polar vortex. It is the movement and the shape and the intensity of the polar vortex that determines where, when, how strong the Arctic air masses and the outbreaks are likely to be, whether they move into the continental U.S., Europe, or Asia. Now, right now, we are in a westerly phase of the QBO and La Nina, and that gives you this kind of jet stream pattern. Now, this looks like crap, okay? You got a major trough here in the blue color in Alaska and western Canada, a huge ridge on the east coast. This is a bad winter pattern. This is correct, okay? This is moderate or strong La Nina with a westerly QBO. But like I said, we might not be seeing that. We're going to see a weak one, and it might be even neutral. Now, if we were to get a neutral La Nina and we just had the westerly QBO, what does that mean? Okay, this is just westerly QBO. As stated in the previous slides, there's a real possibility La Nina may not develop or breaks down by the end of December. If so, let's just look at QBOs. So the precipitation here on the left show a low probability of above normal precip in the lower plains and the mid-Atlantic, and a high probability of above normal in the Great Lakes. See the green color? That's high probability. That's low probability here. The temperatures don't look that bad, okay? And you can see the percentages of having, warmer than normal temperatures look pretty good in the southwestern states into Kansas and Colorado, a little below normal, and you can see, and then on the East Coast, it doesn't look that bad. It looks, the Midwest, the Ohio Valley, southeast states, actually with a westerly QBO, almost looks close to normal with regard to temperatures. And again, this is where we are right now. We are in a QBO, and you can see plus 10.36, okay? When the QBO is in the easterly phase, the polar vortex is weaker, which means you get a negative Arctic oscillation, which means more storminess and more cold, okay? When the QBO is westerly, the polar vortex is weaker, and it's likely to stay, the polar vortex is stronger, and it's going to stay over the North Pole, and you don't get a negative Arctic oscillation, and the cold air has trouble coming south. So right now, we started out the year minus 25, now we're plus 10.36. So it's likely that we are going to peak, as you can see, here in January, February, March. Okay. We have QBO data, which goes back to 1945. So what we're looking at is we're looking at the actual QBO phase and the intensity and the trend. So you see the thick red line here? We were minus 24.56 in January. Since then, we've been coming up around neutral by July, and now we're plus, you can see 10.36. So we're looking at all the winters that started out negative and turned positive going into the winter. And we go through the data and we see these winters, 75, 82, 92, 2006, 2008, 2016. These are all the winters where that happened. When we do that, when we look at the years, this is what we come up with on the QBO. There are 8 analog years that we found, 8 of them. The image on the left is the pattern for December, January, February. again, we have a big negative anomaly here in Western Canada and the northern U.S., right? And a positive anomaly in Alaska. So this is like a West Coast, Northern Rockies winter pattern. It's not great for the East Coast. Not at all. Okay, if you're an East Coast fan. All the blocking is in Scandinavia. But look what happens in the second half of winter, January, February, March. Now we get some blocking in Eastern Canada and Greenland, and the negative anomaly is much weaker, and it's further south, and the positive anomaly in Aleutian Islands is now in the Central Pacific. This is a much better weather pattern. Not great, but much better. This allows for at least some possibility of cold patterns and winter stormy patterns in the eastern U.S. in the late January, February, March winter. Okay. So other variables briefly here. The snowfall in Siberia was crap. The big red line was, you can see, below normal. The development of snow cover in the northern hemisphere during the months of October and November are important, specifically in October across the Arctic region and Siberia. When the Siberian snow cover is above normal, it increases the cold air supply. It can affect the Arctic oscillation later in the winter. But as the red line here shows, October 24, the snowfall finished below normal by quite a bit. While this is not conclusive, it is a negative factor for those hoping for a severe winter in the central and eastern U.S. Another way of looking at it is November. Okay, so this is Eurasia, and you can see the snow cover in Eurasia, look at the red line, is making a comeback. See that? Let me blow this up a little bit so you can see it some more. See, it is making a comeback here a little bit, getting back to the mean. Okay, in North America, because we're in a warm pattern, that is not the case here at all. And you can see, and blow this up, you can see it. As you can see, the red line, we're way below normal because we have been in a very mild pattern in October and November, even in Western Canada. Now that's changing, so we get a chance to catch up. But right now, the snow cover looks below normal. Again, this is a inhibiting factor for cold, especially in the first half of the winter. And also, and finally, in my analysis section, the Arctic sea ice. Why do we look at that? Arctic sea ice, when it is below normal, allows the Arctic oscillation to turn negative. And you can see in the second half of the winter. See the yellow arrow here, way below normal in this area and outside of Greenland, Baffin Island, much below normal. So right now, this is not great, but later on in the winter, it favors a weaker Arctic oscillation, a polar vortex, which means a negative AO Arctic oscillation, and potentially colder winter pattern, stormier. Okay. In terms of my forecast, this is what I'm looking at here. The consensus is for a mild winter with below normal precipitation and snowfall on the East Coast, the Southeast region, with above normal precipitation in the Ohio Valley, and the Great Lakes, and near normal temperatures in the Midwest. That's what everybody's calling for. The underlying premise of this forecast is the consensus forecast based on a weak to moderate La Nina event combined with the westerly phase of the QBO and a pattern that is likely to feature a mean trough on the west coast of North America because of the negative PDO, cold water, and sea surface temperatures in the eastern Pacific. Recent data continues to flow the information and indicates La Nina is coming in weaker and weaker as it ends, and it ends by January 1st. And some of the data suggests the La Nina event will fall apart, meaning we will be neutral ENSO with a slight cold bias for most of the winter. So the data in mid-November, early December will be critical in determining if we are going to have an actual weak La Nina or whether it'll be neutral. I don't know yet which, okay? So we have to play it either way. If we have a weak La Nina, okay? Now, neutral, like I mentioned, neutral significantly increases the probability of temperatures running either normal or below normal with a good chance for, and also good snow or precipitation chance in the central eastern U.S., okay, especially with the temperatures, okay? Now, I do think that December 2023 will be the mildest of the winter. Indeed, there have been very few seasonal colder than normal Decembers in the eastern half of the country since 2000. In fact, over the last 25 years, almost all of the Decembers have featured, almost look like an extension of November, really. That's really what they've looked like. Okay. In terms of the forecast, if we have a weak or short duration La Nina, these are our temperatures. So let me blow this one up a little bit. You can see it. Okay. There you go. And, this is December to February. This is not that bad. If it's a weak short duration La Nina, all these years I have at the top of this image are weak short duration La Nina events. Not ones that last a year and a half, 2 years, 3 years. There's short ones that lasted 5 or 6 months at best. Okay. Now, in terms of precipitation, it looks about normal as well. It doesn't look that bad either. Now, finally, in the event that we have no La Nina or it breaks down by January 1st, and let's say we have a neutral ENSO for most of the winter, January, February, March. If that happens, it's cold. It is a cold map. Look at this. Now, again, we're in the 50s and 60s here, so the climate was much, much colder then. But even so, this does not show a warm pattern or warm temperatures above normal temperatures for the second half of the winter, January, February, March. But it still looks a little on the dry side, especially in the Midwest. So, in summary, so where do we go from here? The things to watch over the next 30 days. The La Nina. It develops. If so, for how long? Don't know. We'll see. Okay? Well, that's something to watch out. The snow cover built up in Canada. Going to be a big deal. A final look at the climate models in the first week of December. And the Arctic sea ice. Does it build up? Does it stay weak for the next 30 days? That's going to be important to see. Anyway, that's the forecast. Hopefully you enjoyed it. And hopefully this is I conveyed what my thinking was, my understanding about this. This is meteorologist DT from Wxrisk. I will see you over on the website and over on the Facebook page.